This is the example of the RL circuit. The switch in the circuit has been open for a long time before it closes at t equal to 0. Find IL for t more than 0. So when the t is less than 0, the switch is open, and then the inductor will be short circuit, and then there will be another step which is t more than 0. You need to find the tau. In this condition, the switch is closed. And for the steps number 3, which is when the t is infinity, the switch is closed for a long time, and then the inductor is short circuit. And now for the step 1, finds the initial currents IL naught through the inductors t equal to 0. T is less than 0, and then the switch is open for a long time, and then the L is short circuit. So this is the circuits of the t less than 0. You can see that the L is short circuit, and then the circuit is only left with the 2 ohms and then 4 ohm in parallel with the current source. So we assume that 2M equals to constant currents DC and switch open for a long time, and L appears short circuit period to release of the stored energy. Remember that in step 1, you need to find the IL nodes. The I that flow through the L when the L is short circuit. And then the switch is open. So you can use a current divider, which is suitable for solving the circuit, because it only consists of one current source with the resistor in parallel. So by using a current divider, you can see that you need to know the IL node. So it means that you have to use the 4 ohms over 4 plus 2 times with the totals of current source value, which is 1.33 M. In step 2, in which you have to find the time constants of the circuits, which is tau. This is the condition when the t is more than 0. So you need to know that and remember that in a step response, when the t is more than 0, there is a supply that exists in the circuit. Now the switch is closed. You have to draw the circuits when the switch is closed. You can see that this is the circuits for finding the R Thevenins. And then you have to remember that the step for finding the R Thevenin is you have to terminate all the source. So if the circuit consists of current source, you have to open circuit that current source. If the circuit consists of voltage source, then you have to short circuit that voltage source. And then how to calculate the value? So the resistor is taken from the L terminal, which is your I should be here. Okay, you have to redraw the circuit in order to identify the relationship in between the resistor. And then for the second figure, I'll already redraw from the original circuits. So I have simplified the circuit so that it's easy to be calculated and easy to be understand. So from the circuit, you can see that the 2 ohm is in series with the 4 ohm, and then it should be parallel with the 6 ohm. So here is R series with 2 and then parallel with 6 ohm, and then the answer of the R Thevenins is 3M. Now you have to substitute the R Thevenin equal to 3 ohm into the tau equation, which is tau is equal to L over R Thevenin, which is equal to 2 over 3 seconds. Now, in the step 3, you need to find the final current, which is IL infinity through the inductor T equal to infinity. So now, the conditions of T previously is T more than 0. Now, the switch is closed for a long time until infinity. And now, the inductor starts to be short circuit. So from this circuit, you need to redraw by considering the L is short circuits here and the switch is closed. So this is the circuits of the T equal to infinity. Okay, you can see that there is a wires in between the loop. So mesh analysis is the most suitable methods in order to find the IL infinity. So I'm considering of using the mesh analysis in order to find the IL infinity. So you have to remember the steps of the mesh. So first step will be looping. How many loops? So in this circuit, it consists of 3 loopings. 3 loop, which is the first loop, second loops, and then the third loops. And then from this circuit, do the KVL for each loops, which is for the first loop will be -5, and then plus with 6 ohm, and then it's equal to 0. So this is first loop. So I1 is equal to 5 over 6. So and then for the second loop, KVL at loop 2, you can see that 2 I2 plus with 4 I2 minus I3 and then equals to 0. So this is the equation. So it will become the equation number 2. And then for the loop 3, so you can see that the current is flowing through here, and then the current is showing the opposite direction. We just takes the equations to be I3 is equal to -2, and then you need to solve all the 3 equations by do arrangements or any methods for finding the I1, I2, and I3. Therefore, you get the I1 as a 5 over 6, and then the I2 is -8 over 6, which is -4 over 3, and then by using the equation, so IL infinity is equal to I1 minus I2, substitute the I1 and I2 into these equations, and then the final values of the IL infinity is 2.17 M. Now, this is the informations you get after you do all the steps, which is T equal to 0 in step 1, T more than 0 in step 2, T equal to infinity in step 3. Now the IL naught is 1.33, tau is 2 over 3, IL infinity is 2.17 M, and then you substitute the equation into the step response equation for the RL circuit. So this is the answer or the equations of the ILT, which is 2.17 minus 0.84 exponent minus 3 over 2 Tm. Okay, not V. M. Now, the question is, what is the answer if the questions asks you VL. How to determine the VL? This is the hint. Okay. So VLT is equal to L VIT over this. Okay, this is the homework. Okay, so I need you to find the answer for the VLT. Thank you.